Carmen. Hey, hello, hello. You guys are my most energetic class, always willing to say hello. Hey, Carmen. Oh, that's not good. You were going pretty fast, were you? Or was it just, is that how it blew up? Yeah, that's a good question. Are you okay? Yeah. Good question, Gabby. Hey, Chloe. How are ya? We were just talking to Thomas. He blew up his four wheeler. So, and Gabby asked him if he had, it was okay. Doing all right. Oh, Chloe's doing all right. How about Thomas? That's what we're kind of concerned about. When they blow up, they usually don't cause a lot of damage to you, but they are expensive to replace. Expensive to replace. Or you get to learning how to fix them. Okay. Do you know how to fix those things, Thomas? Because it sounds like you do when you said drop the piston and blew the head. Sounds like you know what's going on. He says he's okay. I still have a cough, guys. Sorry, guys. I'm gonna have to get a cough drop here. Okay, so you're gonna fix it. Cool, cool. Hey, do you take videos of that? You do YouTube on that, like how to fix a drop piston? I got it. I got an infinite cough. Yeah, yeah, that's for sure. I started. Yeah, yeah. I would really like to see that. So you post anything like that, I'd like to see how you do those. I'm always interested in that kind of stuff. My son has a lot of mini four wheelers, and he's always doing that. Oh, cool. Send me a link. I would appreciate it. That'd be cool. All right, ladies and gentlemen, let's do some um, review of some vocabulary, okay? And let's take a look at this participation points. All right, what's a pusher or pull called? What's a pusher or pull called? What is it? What is it? I got two people. Thanks, Gabby. Thanks, Thomas. And Chloe and Rachel. Natalia, can you get in there? The other Chloe, Ken, Carmen, can you guys get in there? Kendrick, good to see you. Natalia, Rihanna, good to see you guys. Got four people. All right. Yeah, it's the push or pull is the force. How about this one? Oops, not this one. That's the show it. Okay, a force that is exerted by a push or pull. Is it contact or non contact? So it's not inertia or normal. It's either contact or non contact. I got four, five. Good. Hey, DeAndre got in there. Thank you, DeAndre. Got five people, seven people, and you guys are right. That is a contact force. Thanks for participating, guys. Really does help me out as far as knowing that next week we're going to have the chapter test over 5, 6, and 7. So, chapter test next week, 60 points, and then vocabulary post test as well. All right. So, contact force is a force that you actually touching something, right? How about this one? A force, the space around an object that can apply a force without touching. What is that one? It's a non contact force, but it's also called something else. What else is it called? It's not touching. So friction is touching. Friction is touching. So, and normal is touching. Normal is a contact force. All right. So most of you guys got it. It is a field force. And you guys can see it. It's invisible, but if we take like iron filings around a magnet, you can actually see the field lines, right? Right. Contact forces are pushing and pulling, tension, pushing and pulling, but contact forces like gravity and electrostatic forces, and magnets are field forces. All right, so this last one here, this next one, what kind of force is the force between surfaces exerted to prevent solid objects from passing through another, right? So what are those called? All right, so a lot of times we call them supporting forces. Put a book on a table. The book doesn't go through the table. The table exerts a force upward, gravity force downward. So what is that called? A couple people got this one right. DeAndre, thank you. Grace and Thomas, Rihanna, 7 people. It is called the normal force. Okay, the normal force is the force that is the opposite of the weight of gravity, or the downward force of gravity. So if we didn't have the normal force, we'd be falling in free space, right? So if you don't have a normal force, that means you're falling, okay? Or weightless in space, right? So frictional forces oppose the motion. So normal forces support us as we go through. All right, so what's this one? Objects slide over each other and they touch an opposing motion. So I'm pushing something and it's slowing me down. A lot of times I have to put stuff underneath to lubricate it so that it'll slide easier. And Thomas was talking about his piston blowing. If you lost oil pressure, lost oil, definitely would seize up, right? And you guys got it. That is frictional force. Frictional force is the force that opposes motion. And again, if I put it on ice, and a lot easier to pull that way. And again, I think that what the anthropologists have figured out is that some of these things like Stonehenge, where people have had to, where they in England, where they've moved heavy weighted objects, they basically rolled them on tree trunks. They to reduce the frictional force. They moved them on ice. So if you're moving something across the ice, a lot easier to move. All right. So things like that. They had a lot of things way back that we had problems with. All right. All right. So we are done for that today. So we're going to be talking about, hey, Aaliyah. Hey, Adriana. Let's see, who else did I miss here today? Dalton, good to see you. John, good to see you. Jasmine, excellent. Journey, good to see you guys. Kylie and Madeline, good to have you guys here. Got a cough drop in my mouth, so it kind of make clicking sounds. So what we are going to do here is we're going to show you what we're going to be talking about. Is we're going to do a pair deck. All right, pair deck. And the pair deck is going to be talking about net forces, balance forces, and free body diagrams. So drawing today. So you guys are going to help me do some drawing here. So let me get the pair deck extension out. Hopefully you guys have multiple monitors. That would be nice if you did. But a lot of times people don't have those. So so watching the big blue button and doing pair deck at the same times can be a problem. But I wanted to do this so that you had something different than the polls all the time. So we're going to do some drawing in here. And don't worry, you guys are better drawers than I am. That's for sure. Let me clear the chat here. Yeah, thanks. DeAndre has one. That is great. I think that Odella should give you guys an extra monitor. Be honest with you, just put it in there, because it would be really make it much easier to do that. Split screens are good, but boy, that's still hard. Still hard. All right, thanks guys for getting in there. So free body diagrams, they are a graphic organizer or a sketch that shows the forces that we're going to be talking about. All right, so that we can isolate the forces. So it's kind of something that in science they do to eliminate, say what the forces are, and then to identify them, and then either reduce them or acknowledge them. And then, you can make engines to overcome it, or you can, like for frictional forces, using something to make the friction less. All right. I was at the um, Greenfield Village this weekend, and they have a lot of old steam engines. And if you've ever seen steam engines, they are so huge and they move so slowly, but they are amazing to see. And what's interesting, shops used to be run by little steam engines, and they used to use little kids to run up and lubricate the pulleys and the wheels, things above. And a lot of those kids did not have a happy life, and some of them fell to their deaths. So we're a lot better than we used to be. I hope we're a lot better than we used to be. So let's take a look at this. We can use arrows to represent direction, strength of the force. Okay, and the arrows, remember, are vectors. The direction of the arrows and length tell you, the length tells you the magnitude, how strong the force is. All right. Force arrows can combined show overall results in forces, what we call net forces. So up is usually designated as a plus. North is considered a plus. Left is considered a negative, and right is considered a plus. Down is considered negative. So here's your first time here. You guys can draw. I'm going to use my tablet here. Draw a car where one person is pushing and one person is pulling. Okay. So if you want to draw that for me, and some of you guys are pretty good at this. So come on, move over there. All right. All right, got to turn my tablet on. And this is something I had to buy my own tablet, my own monitor as well, guys. I think you guys should have one. But so here are my wheels. And here's my car. And here I'm going to push on this side using a stick person. And here I'm going to attach a rope for this person to pull. Hands on them. So there's a push and pull car that I did. So this is the idea that you get when making drawings. But what we're going to end up doing is using vectors in order to do this. Okay, I got 3 people so far. All right. Let me take a look here. I'm going to take a picture of my screen here so that I don't lose it, because I didn't. Oops. I always do that. I always draw when I should be erasing, when I should be. All right. I want to take a picture of it. New. All right. So here is my picture. So I can clear this off. And then I can show who has been doing the drawings here. Oh, nice. Push and pull, right? Nice. There's 2 people pushing maybe, or 1 person pushing and pulling. I like this one. Okay, I got 3 people. All right. Anybody else? Anybody else in there drawing? You guys are doing a great job. Let's see. I had 5 people that were trying to draw. Let me move this over here. I have John and DeAndre and Chloe, Rachel and Kylie. Kylie are kind of working on it, maybe. Okay. All right. All right. So who else did I get here? Rachel's working on it. Thanks, Rachel. All right. So let's take a look at, see if we can get Kylie in there. Kylie has not responded yet, but Rachel's working on it. Oh, cool. This added another person in there. Excellent. And there's Rachel. Thanks, Rachel. Don't want to move ahead of you guys if I don't have to. All right. So mine looks like this. Where is it? There we go. Mine looks like that. Right. And again, I got a drawing tablet, so it's a little easier for me to draw than some of you guys having to use your mouse and so forth. I know what that's like. All right. So when we do free body diagrams, free body, again, they are, I think what they want when they want to say free body, it's to isolate the forces on that body only, not with all these other lines and so forth that kind of conflict. So a diagram shows the size and direction of all the forces on an object. So again, today's exit quiz is a Google Doc assignment where you have to put some arrows in and identify frictional, this one's force of application, the normal force, the frictional force, and gravitational force. Now, if there was no normal force, just let you know, there would always be a gravitational force. If there was no normal force, this thing would be moving downward, right? So sometimes I like to think about that I have a table here or something, or the ground on there, okay? Especially frictional force, right? Means that I have friction that's impeding or slowing down the acceleration versus to applied. So if I don't have a normal force, that means there's no support there, no support, and it's falling. So no application, no normal force can be falling. All right, so what we do here to draw an FBD, free body diagram, we use a box to represent the square rectangle. We use a dot, which is the middle of the mass, center of the mass represents, and then we try to draw it. So we draw an arrow starting at the dot in the center, point the arrow in the direction of the force, make the length of the arrow based on the size of the force. If two forces are equal, the arrows must be the same, and label the forces. So let me ask you this question, just from this one. All right. Those people that are in, let me do this prompt here, new prompt. I'm going to have you guys draw on here. Tell me yes or no in here. Is this moving? Answer here. All right. Is this moving? Okay. All right. So is this moving or is it not? Yes or no? What do you think? Moving or not? So I'm going to ask you guys in the polls, start a poll. Is this moving? And again, if you're in the Pear Deck, do not worry about having to answer the poll. Moving, A, yes. B, no. What do you think? Give me an idea here. What do you think? Off the top of your head, looking at that free body diagram, does it look like it's moving? Yes or no? All right, I got 3 people in this thing said. Let me see what they say. 3 people say, yes, it's moving. All right, I got 7 people out here say, yes, it's moving. Good job, guys. Excellent. Yeah, it is moving. And if you want to take a look at the answer here, if you look at the diagram right here, you notice that these are equal, right? This, the force of the normal force and the force of gravity are equal. So it's not moving up or down, but frictional force, Fr, is smaller than applied force, so it's moving to the right. All right, so that's what we're going to end up getting to, net forces. Just wanted to preview of what we're doing here. Okay, so a box is at rest. You can see the box at rest. Here is a picture of the table if you're going to draw the whole thing out. But what we're going to do with the free body diagram is we're going to draw the box. Maybe we'll put the table line in there. I like to put it in there to remind me that it's not moving. It's not going through the table, right? So the normal force here, right, and the weight are balanced. Again, I could use numbers on this, but I tried to show this in the length. They're equal and opposite, so this is balanced and it's not moving. Or it's moving at constant speed, but again, could be what they call, it could be terminal velocity here too. All right, so sometimes we use a plus and a minus to show the directions. In other words, right, left, up, and down. Force directions up and right are positive, and force directions down and left are negative. So what do you think? I'm going to give you guys a new prompt here. What is the net force on this? This is actually moving downward. What would you think the net force of this is? I'm going to start another poll. Okay, what's the net force in numbers? I'm going to have you guys type this out for me. It's moving down, so you got to use a negative number. Down means negative. All right, type an answer in here. What do you think? It's 400 newtons pushing up for air resistance, 600 newtons moving downward. So what do you think this is? All right. Thanks, John. How about you guys here? What do you think in the Pear Deck? All right, Pear Deck, 200 newtons. Excellent. Excellent. You guys got it. 200 newtons down, not 200. 200 would mean it's going up, right? 200 would mean up. 200 newtons down would be what you're looking at. Okay, so you guys are getting the idea. Now, when we do the free body diagram, right, we use these symbols here. Gravity, force of gravity, Fg, force of attraction between all objects, always there. Gravity is always there unless we're talking about space. The normal isn't always there if it is falling, okay? Or it might be, it could be force of friction or air drag can be also considered that. So the force perpendicular to the surface of an object it's contacting with. So if it's on a table, this is called the normal force. But again, we can use it for other things. Tension, force T, is exerted by materials like ropes and fibers and springs. Friction always opposes the applied force. So if you're pulling it to the left on a surface that's rough or even ice, there's still some friction. It will always oppose it. If you're pulling it left, friction's going to go right. If you're pulling it right, friction's going to go left. Kinetic friction, force of an object that's in motion. So pushing something that's in motion, frictional force is less than if starting to push. You might have noticed that if you had to push a car, once you get it started, it's certainly a lot easier to move. So that's static friction. Air resistance, friction that opposes the motion through the air, and applied force, a contact force previously, okay? All right, so if we determine a force on the bag, we draw a dot, right? And we have the force of the table. Okay, what's another name for the force of the table? Can anybody tell me in the chat here or in the prompt? All right, so force of the table, we can also use something else for that. All right, so let me start a poll. I'm going to have you type in it. So what's the force on the table? Force of the table can be also named something else. Force of the table can be named something else. Type, what do you call it? I'll help you out. What would you call that? So we always have a gravitational force. It's another name of called it the supporting force. Supporting force starts with the letter N. If you don't know, letter N. Help you out. Letter N. All right, no responses in the other here at all. All right, so we've got, all right, we got a couple people got it with the letter N. Yes, normal force is also the table force or the supportive force, right? Supporting force. Okay. Thanks, guys. Normal force is the same as the table force. So here we go. We have gravity. Now, see, those arrows are the same in length, okay? Then this is at rest. It's supporting on a table here, okay? You can kind of think about it. Sometimes they ask you those questions. What does this thing look like it's doing, right? Gravity and the force of the table. So this is my last slide, and we're going to stop it here, and then we're going to show you what you can do. So if a horse pulls a sleigh, consider frictional force and observe forces acting on the sleigh. So the horse is pulling it forward. All right. So how many arrows should I put in here? Okay, let me start a new poll. How many arrows? How many arrows? How many arrows can I use in here to show if I were to draw a box, how many arrows would I do in here? Type your answer in here. How many arrows? I'm going to do the same thing for this. How many arrows would you use here? Consider frictional forces, right? What would we consider? All right, somebody's got it. Thanks, Chloe and John. Anybody else? How about here? 2 on this one. Show your responses. 4 arrows would be right. Let's see what we got here. Let me stop this. 4 arrows would work. Right, so we've got friction, pulling it backward. We got the force, the normal force going up, or the earth supporting it, and the gravitational force going down, and the horse applied force. Okay, so we're going to stop right here as from our introduction. All right, so what you are going to want to do, all right, so where are we? Okay, exit quiz. Okay, here is the exit quiz. I will give you this link. I think I can do this. Hopefully it'll work for you. All right, so this one wants you to do this. Okay, so let me go to the chat here. All right, clear this out. Exit quiz, you have 2 slides. Use the arrows to label an object at rest. Use the normal friction spring applied and so forth on this one. Okay, show me that and decide whether it's balanced or unbalanced. Okay, remember, balanced forces show no acceleration, unbalanced forces show acceleration. And then the next one, it's you're pulling with an object with a rope of some sort, a spring. Okay, using a spring, you're pulling it so it's not at rest, right? And you use these arrows and you label those. Okay, so remember the arrows that you have to use on this one. Okay, I give you a hint. This one takes 4, the other one only took 2. Okay, all right, so you're going to do those, right? And what other thing that I want you to do, okay, let me stop sharing here, is let me get to a new slide here. Default, set default. Okay. All right, so a couple things that you can do today. Get this out of the way. All right, is So remember W6 assignment 1 and 2 just are past due. So these are past due. All right, so get that done. They're already zeros, so make sure that you get those. W6 quiz is due today. Okay. Right, you got the exit quiz. And I will be going over W6 assignment 1 in the big blue button. Okay, and I will put the list of people that have a 0 or a low grade in that assignment in the shared notes. And then I will give you the big blue button link. Okay. All right, so I'm going to turn my camera off, put this on pause. We've got